Okay, here is number 10 from exam one, problem number 10. Wanting to work through now the situation of, I'm going to call up on the screen the, uh, the actual question so we can look at that diagram. Okay, if you have yours in front of you, that's great, but you can also look here, have it in front of you and see what you were thinking. That might be good. But notice the biggest thing is that there is a dot, a solid dot up there at -2, 3. There's a dot at 0, 0, a filled in circle at 2, 2, a filled in circle at 6, 3. I've got an open circle at 4, 1, and an open circle at -2, 2. Okay? Now, the question is, the first question, A, for which values of x does the limit exist? The limit of f of x exists, but is not continuous. F of x is not continuous for that value of x. So stop and think. Here's where there's a difference between limit and continuous. To be continuous, what has to happen? It's got to be that you don't lift your pencil. If you have to lift your pencil anywhere, okay, if one pixel's missing, then it's not continuous at that point. Limit's a little different situation. The limit situation is if you're coming in from the right and you're coming in from the left and you go to the exact same pixel, even if that pixel's not there, then that limit exists. If you're coming in from the right, you're coming from the left, because the limit, what you're approaching is the same. From the right, if you approach it from the right and you approach it from the left, is the exact same spot. That means that limit exists, okay? So the question is, for what values of x does the limit exist, but it's not continuous? So it's going to be a situation where there's a hole, you know? So not continuous means you got to lift your pencil. All right, take a shot at that. Make sure you're solid with that. Let's look at the second part. For which values of x is f of x continuous at x? Don't lift your pencil, but not differentiable. Okay, so now I don't want the places where you got to lift your pencil. So if there's a hole, we're not talking about that. It's got to be places where you don't lift your pencil. It's continuous. And now not differentiable. Check this out. I want to show you this. I want to remind you that they have in the text, they made a point to show, three places, three examples. Notice just before it, this section in the text, it's in page 167 in the text, it's in 3 of section 2.2. This is section 2.2. Identify where a function has no derivative. There's 3 examples they give. Notice what this says right here just before it gives the examples. 3 of several ways this can happen are, okay? So it's saying that, notice what you've got here, the change in y over the change in x. This is the slope. As x is approaching c, as these numbers get closer and closer inside here, and these are getting closer and closer, the slope is what you're talking about, okay? So that means the slope can't, so the first section says this right here. This one situation exists if you're coming in from the left, it exists, and coming in from the right, it exists. What does? Change in y over change in x. The slope as you come in from the left and the slope as you come in from the right exist, but they're not equal, okay? That means the slope is different when you come in from the left and from the right. The example they give right here is a really obvious one. We got a slope of +1 on this side and a slope of -1 on this side. And they're pointing out, they're using the word a corner. So if there's a place where the slopes aren't exactly the same when they come in from the right and come in from the left, then that's got a corner, and that is said to not be differentiable. It's got to be smooth. The slope has to be the same as you come in from the left and from the right, okay? Now, a slight variation on that theme, here the slope as you come in from the right and from the left, these two are saying, notice both of these right here, vertical tangent line here. As you come in from the right, you end up with a vertical tangent line. Coming from the left, vertical tangent line. And, this is positive slope, this is negative slope. And this one is saying you've got positive and positive, but there's a vertical tangent line. If you have a vertical tangent line, that's consistent with the denominator being equal to 0. It's an illegal thing. You can't do that in our math system. So if that happens, it doesn't work. The diagram on this test doesn't have anything like that. So it's where is there a corner in the problem? So going back to that diagram now, let's go back to new share. I want to go back to the problem diagram here. The situation is it's continuous, so there's no hole, but not differentiable, meaning there's a corner, okay? So check it out, answer those questions. Make sure, again, like I say, make sure I said it on the instructions, make sure it's clear. Make sure you show me a different color lead or a different color pencil. Make sure do it neatly, but show me what's new. Show me the old and the new. I don't want to just see the new. I want to see the old and the new so I can see what you did differently and the points that I gave you, etc. Okay? So do that and get it back to me as soon as you can. Sometime if you want to do it over the weekend, you're welcome. Early next week will be fine, but if you can get it done today, that'll be awesome. Get that as an email attachment, take a picture, make it a PDF, send it to me as an email attachment, and same thing with the question number 3, okay? All right, good, and good, do well, get it done soon. Thank you. If you got questions, let me know.